Look at these last few problems from section 1. To find the tangent of 2 pi over 3, probably the first thing we would do is change, at least for now, 2 pi over 3 over to degree measure so we know what we're working with here. If I multiply by pi, or 180 degrees over pi, the pi's will cancel. The 3 and the 180 will become 1 and 60. So we're actually finding the tangent of 120 degrees. Now from here, we can find the tangent of 120 degrees by drawing in our triangles. This is 120 degrees, which is going to give us a 60-degree reference angle. I'll make a right triangle out of that. So we come straight down here, 60. Here then is 30. So a 30, 60, 90 triangle. We have 1, square root of 3, and 2. We have a negative sign here. So tangent is opposite over adjacent, or y over x. So tangent is negative square root of 3. And we'll repeat the process here for the next several. So let's look at the sine of 3 pi over 2. I'll repeat the process by multiplying by 180 degrees over pi. The pi's will cancel. The 2 and the 180 become a 1 and a 90, which gives me, let's try that again, 270 degrees. 270 degrees, I hope we all would recognize to be a quadrantal angle. So I'll just quick sketch over here. Quadrantal angle is 270 degrees from here all the way around. Our repair is 0 and negative 1, which means our R value would also be 1. And sine is x over, let's try it again, y over r, negative 1 over 1, or just a negative 1 for our sine. Continuing on here, I have the cosine of negative 4 pi over 3. Again, until we get used to the radian measures, we probably don't know what that angle looks like, so it might make more sense to convert it to degrees. Eventually, hopefully, we will know what that angle looks like, but I'll cancel the pi's, the 3 and the 180 to be 1 and 60, which means I'm actually finding the cosine of negative 240 degrees. Again, hoping that we're able to sketch that angle. 240 would be right down in here, which would give me a reference angle of 60 degrees, and a reference triangle. I'd have a 30, 60, 90, or 1, square root of 3, and 2. We're in the third quadrant, so both x and y are negative. Cosine being x over r, so our cosine would be negative 1/2. A couple more here. Cosecant of pi over 4. 3 more. Cosecant of pi over 4. So if I multiply by 180 degrees over pi, again we can see the pi's will cancel, and the 4 and the 180 to 1 and 45. So we're finding the cosecant of 45 degrees. Again, hoping we would all agree that that would lie in quadrant number 1. So we have a 45 degree angle. We'd come straight down and make a 45, 45, 90, or 1, 1 and square root of 2. Cosecant being r over y, so the cosecant is going to be square root of 2 over 1, or just the square root of 2. Cotangent of 5 pi over 6. Let's go ahead and change that to degree measures as well. Multiplying by 180 degrees over pi. We'll cancel the pi's, cancel the 6 with the 180 to be 1, and let's try that again. That's not working out very well for me. 1 and 30, and we're eventually finding the cotangent of 150 degrees. Over here with our quick sketch, 150 would be in the second quadrant. From here to here would create a reference angle of 30 degrees. Okay, coming straight down, we'd have a right angle here and a 60-degree angle here. So we have 1, square root of 3, and 2. We're negative on the x-axis, and cotangent is x over y, square root of 3 over 1, or negative square root of 3 over 1, which simplifies to be negative square root of 3. And we have one last problem here to wrap up our section. Secant of pi. We might know this already, so I'm going to jump straight to it being secant of 180 degrees. Secant of 180. 180 on a coordinate plane. I hope we all agree it lies here. That has an order pair of negative 1 and 0, which means that y or r would also be 1. Secant is r over x, would be 1 over negative 1, or the secant of pi is negative 1. And that would wrap up section 1.